Hello students, good morning to all of you. Now, as in the previous class for the inverse trigonometric functions, we have studied about the principal value of the inverse trigonometric functions. There was a single question. Now it is just like an equation. Tan inverse of 1 plus cos inverse of minus 1 by 2 plus sin inverse of minus 1 by 2. So separately, in short, each trigonometric function's value, principal value, we will find it out. Tan inverse of 1, let us take it equal to x, it becomes tan x equals to 1 and 1 equals to tan pi by 4, we can write down. Our range of the tan inverse function is minus pi by 2 to pi by 2, so it lies in this range, so x becomes equals to pi by 4. Now for the second, cos inverse of minus 1 by 2 which equals to y, cos y equals to minus 1 by 2, which becomes minus of cos 60 degree, that is pi by 3. So minus, that is becomes cos 180 minus theta is minus cos theta. So cos pi minus pi by 3, it becomes cos 2 pi by 3. So range of the cos inverse function is 0 to pi. So y belongs to down here 2 pi by 3, 120 degree. In the same way for the third one, sin inverse of minus 1 by 2 equals to, we take z, sin z equals to minus 1 by 2 minus sin pi by 6, and sin of minus of theta is minus sin theta, and its range is minus pi by 2 to pi by 2, which includes minus pi by 6. Therefore that equals to minus pi by 6. As we see that here equation is all the three trigonometric ratios are in the additional form. So x plus y plus z. So now we can take its their additions, x plus y plus z, pi by 4 plus 2 pi by 3 minus pi by 6, LCM 12, we get 3 pi plus 4 into 2, 8 pi minus 2 pi, 3 pi plus 8 pi, 11 pi minus 2 pi, 9 pi by 12, 3 3s are 9, 3 4s are 12. So its final answer will be 3 pi by 4. This is our question number 11. In the same way, for the NCERT, the first exercise you have to solve question number 12 in the same way, and also you have to solve question number 14. Question number 12 and question number 14 in the same way. What we are doing in the question 1 to question number 10, separately we are solving each question and getting the principal value. But in the question number 11, 12 and 14, there is an equation such that 11 question tan inverse of 1, cos inverse of minus 1 by 2 plus sin inverse of minus of 1 by 2. So separately you have to calculate in the same way as we have solved a question from question number 1 to question number 10. So first we have solved for this, second part we have solved for this one, and third we have solved for the last one. So here all the three inverse trigonometrical terms are in the additional form. So what we do, we add up all these values and we will get our final answer. X plus y plus z equals to, first value was pi by 4, then second was 2 pi by 3, third was minus pi by 6. When we simplify this, at last our answer is 3 pi by 4. So in the same way you have to solve question number 12 and 14. In inverse trigonometric function, we have solved the first variety of question, that was separately we are calculating the principal value of the trigonometric functions. Second variety of question, that trigonometrical equations, that we have solved it as question number 11, 12 and 14. Now we are going to solve it, the prove that questions. There is a mix-up format. So I am solving the third variety of question from the exercise 2.2 and 2.3. So third question, we have to show that LHS equals to RHS. So LHS is tan inverse of 2 by 11 plus tan inverse of 7 by 24. As we know that tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y upon 1 minus xy. as I have given the formulas to the WhatsApp also. After studying the formulas, you have to just apply this formula. So tan inverse of x की value है 2 by 11, y की value है 7 by 24 plus 1 minus 2 by 11 into 7 by 24. So tan inverse of 2 into 24 plus 7 into 11 upon 11 into 24 into 11 into 24 divided by 11 into 24 minus 2 into 7. So I have taken the LCM there. So 11 into 24, this 2 into 24 plus 7 into 11. This after LCM 11 into 24 will go reciprocal, and 11 into 24 minus 2 into 7, this will be cancelled out. So tan inverse of 48 plus 77 upon 24 into 11, 240, and plus 24, 264 minus 14, that is tan inverse of 48 plus 77, 8 plus 7, 5, 15, 4 plus 7, 11, 12 upon 250, that becomes tan inverse of 1 by 2. That is our RHS. So in this way, LHS to RHS you have to simplify, you have to get it, prove it from the LHS to RHS by applying the formula. Here the formula applicable is tan inverse of x plus tan inverse of y equals to tan inverse of x plus y upon 1 minus xy. Be careful while writing down the formulas. Now we come to the next question of the same variety. Here it is given in the LHS 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7. Here we cannot apply directly the formula for tan inverse of x plus tan inverse of y, as we are seeing that here it is a 2 tan inverse x format, and we know that 2 tan inverse x is given by the formula tan inverse of 2x upon 1 minus x square. So first we have to apply this formula, tan inverse of 2x 1 by 2 upon 1 minus x square 1 by 2 the whole square, tan inverse of 1 by 7. So this 2 and 2 cancel out. Tan inverse of 1 upon 1 minus 1 by 4 plus tan inverse of 1 by 7. That becomes tan inverse of 1 upon 4 minus 1, 3 by 4 becomes, and tan inverse of 1 by 7. It becomes tan inverse of 4 by 3 plus tan inverse of 1 by 7. Now we can apply this formula, as now it is converted in the format of tan inverse x plus tan inverse of y, and now we can apply this formula. We get tan inverse of 4 by 3 plus 1 by 7 upon 1 minus 4 by 3 into 1 by 7. That becomes tan inverse of LCM is 21. So 7 4s are 28 plus 3 into 21 upon 21 minus 4. That becomes tan inverse of 28 plus 3, 31. 21 cancel, 21 minus 4, 17. So that is our RHS. From LHS to RHS. So what is the difference in between these two problems was that first we have to convert this 2 tan inverse x into the format of tan inverse of x by using the formula 2 tan inverse of x is equals to tan inverse of 2x upon 1 minus x square. Now for the third question we have to show that 2 sin inverse of 3 by 5 equals to tan inverse of 24 by 7. So as we know the formula for 2 tan inverse x, since we know that 2 tan inverse of x is equals to tan inverse of 2x upon 1 minus x square. So what we have to do it, first we have to convert this sine inverse of 3 by 5 into tan inverse function. So now listen carefully, I have told that I will explain you about the conversion properties. How you are going to change sine inverse of 3 by 5 in terms of tan inverse. First we draw one right angle triangle. So in right angle triangle we are considering this as acute angle perpendicular upon hypotenuse, as sine is perpendicular upon hypotenuse. When we calculate by Pythagoras theorem, our base will become 5 square minus 3 square, that is 16, square root is 4. When we get all the sides perpendicular, base, hypotenuse, now we are able to convert this sine inverse function in any of the rest 5 inverse trigonometric functions, whatever we want. But here we want tan inverse. इस साइन इनवर्स को कन्वर्ट करना चाहता हूं मैं tan इनवर्स में, और tan इनवर्स होता है परपेंडिकुलर अपॉन बेस. सो देयरफॉर LHS 2 साइन इनवर्स ऑफ 3 by 5, 2 को ऐसे रहने दीजिए. इस साइन इनवर्स 3 by 5 को tan में चेंज करना है, तो tan होता है परपेंडिकुलर अपॉन बेस, तो इसको मैंने कर दिया tan इनवर्स परपेंडिकुलर अपॉन बेस. तो ये हमारा साइन इनवर्स 3 by 5 इक्वल टू हो गया tan इनवर्स ऑफ 3 by 4. मतलब ये इस फॉर्मेट में आ गया 2 tan इनवर्स ऑफ x is equals to our this formula. Now we can apply, as we are having the right side to prove tan inverse, that's why we have converted this function to a tan. Now tan inverse 2x upon 1 minus x square, 9 by 16. So tan inverse of 6 by 4 into 16 minus 9, 7, but reciprocal 16 and 7, 4 4s are 16. Tan inverse of 6 into 4, 24 upon 7, and that is our RHS. So once again I am going to explain about the conversion property. As the right side we have to bring the function tan inverse x, but in the LHS we are having sine inverse. So this sine inverse we are going to convert with the help of this Pythagoras theorem of right angle triangle. Sine inverse is perpendicular upon hypotenuse, so 3 by 5, and Pythagoras theorem अप्लाई करेंगे तो बेस आ जाएगा 4. नाउ जिसमें भी आपको कन्वर्ट करना है वो आप कन्वर्ट कर सकते हैं, लेकिन हमें कन्वर्ट करना है tan में, इसलिए परपेंडिकुलर बाय बेस 2 tan inverse of 3 by 4. Now 2 tan inverse of x is tan inverse 2x upon 1 minus x square. You can apply and you can get the right side of it. Now comes for the question number 7. Tan inverse of 63 by 16 equals to sin inverse of 5 by 13 plus cos inverse of 3 by 5. इसे हमें RHS से LHS सॉल्व करना ज्यादा आसान पड़ेगा. तो RHS जब मैं इसको स्टार्ट करूं तो sin inverse of 5 by 13 प्लस cos इनवर्स ऑफ 3 by 5. अब इसे मैं tan में चेंज करूंगा, इसे भी tan में चेंज करूंगा क्योंकि LHS में है tan इनवर्स. एंड आफ्टर कन्वर्टिंग tan into tan inverse I can apply the formula for tan inverse of x plus tan inverse of y. Let us see again the conversion property for the first one and also for the second one. 5 by 13 परपेंडिकुलर बाय हाइपोटेनियस हो जाएगा. सेकंड वाला बेस बाय हाइपोटेनियस हो जाएगा. अगर यहां पाइथागोरस थ्योरम लगाऊं तो यहां आएगा आपका बेस 12, और यहां पे पाइथागोरस थ्योरम अप्लाई किया जाए तो यहां पे आएगा परपेंडिकुलर 4. अब इसको मेरे को कन्वर्ट करना है tan में. सो दिस ऑल आर द फेयर वर्क. सो tan इनवर्स 5 by 12 परपेंडिकुलर बाय बेस, यानी कि sin इनवर्स ऑफ 5 by 13 कन्वर्ट हो गया tan इनवर्स में 5 by 12, और cos इनवर्स के लिए ये वाला था तो cos इनवर्स 3 by 5 परपेंडिकुलर बाय बेस tan इनवर्स ऑफ 4 by 3 में कन्वर्ट हो गया. और अब मैं tan इनवर्स ऑफ x प्लस tan इनवर्स ऑफ y का फॉर्मूला अप्लाई करके LHS ला लेंगे. tan इनवर्स ऑफ 5 by 12 plus 4 by 3 upon 1 minus 5 by 12 into 4 by 3. Since we know the formula tan inverse of x plus tan inverse of y is equals to tan inverse of x plus y upon 1 minus xy. So tan inverse of 12 into this LCM will become 12. So 5 plus 4 into 4 16, and here the 36 and 36 minus 20. So tan inverse of 21, 12 into 3 36, 36 minus 20 16 into 3, that is tan inverse of 21 into 3 63 upon 16. So that is our RHS. So once again let us see, as from RHS we have to easy to prove it LHS, and LHS it is tan inverse function. So first we convert by the using the conversion property, applying Pythagoras theorem. Sin inverse x to tan inverse, cos inverse to tan inverse, we get perpendicular by base 5 by 12. For the second one, perpendicular by base, we get 4 by 3, and then we can apply the formula for tan inverse of x plus tan inverse of y. That becomes x value of 5 by 12 है, y की value 4 by 3 है, तो tan inverse of x plus y upon 1 minus x into y, and after simplification we are getting tan inverse of 63 by 16, which is our LHS. So I have solved it, question number 3 and question number 7. In the same way, these three questions 4, 5, 6 and question number 8 will be homework for you, and in the next class I will be going to discuss some more questions related to the same topic. Prove that questions. Thank you.